Problems from last week?
No.
Great. Problems from last week?
Not really.
What does that mean?
No.
You sure?
Yes.
Why don't you look? Come on, I'm not going to believe that nobody had problems from last week. That is too unbelievable.
Can I ask you a physics question?
No.
Linear and quadratic inequality.
Now we're talking. You got a question in mind?
I'll give you
We'll have a look first at linear and quadratic inequalities, if you can open that, please. Which one did you have in mind?
Well, it's,
I'm quite tired today, so you take as long as you want. Which one did you have in mind?
the last part, like from the following inequality.
Yeah, so just give me one.
Okay, the first one.
What was the first question I gave you for homework, for example? We'll do that one.
Okay. CDE from each.
Right, so give me C.
So C, 36
Yeah.
is less than x squared plus 10x plus 25 is less than,
Less than or less than and equal?
no, less than
Okay.
81 comma 81, and then x is an element of n0.
Okay. Let's do this one. This was one from the homework then. Okay. So I'm going to separate it into two quadratics. The first one is 36 less than x squared plus 10x plus 25. And then the second one is x squared plus 10x plus 25 less than 81. And then this is x squared plus 10x 11 minus 11 minus 11
Yes.
bigger than 0.
Yeah.
X squared plus 10x
Minus.
yeah, hang on, I'm tired, leave me alone. 56
Yes.
56, yeah. Minus 56 less than 0.
Mhm.
Yeah, now I got a new toy, let me show you. Oh no. Oh, look at this now, yeah, you'll see. Get ready for this now. It'll blow your mind.
Lead.
What?
Because these wearing
Oh yeah. When will your calculator arrive?
Tuesday.
Tuesday?
It's my
Tomorrow?
tomorrow.
So on Wednesday we'll see you with your new calculator. Exciting. It's taking a while to open. Open. Oh, it'll take a while. I'll have to do it the old-fashioned way.
Can you factorize using a calculator?
Yes.
Yes.
How?
I was just about to show you.
Oh, okay. Then it gives you.
Yeah, so it was 1, 10, minus 11, 1, and minus
This one is x.
Most have one.
I'll show you when it loads, if it loads. It was working earlier today. X minus, no, plus 11,
no, plus 1.
x minus 1
Yeah.
Yeah, and here x. Now look at this. Look at this.
Wow.
I told you, it would blow your mind.
Can't you make it any smaller?
I can't actually.
You can't actually.
No, I can't because
Like mine is too small. It's like
the screen resolution is only 800 by 600 right now, so this is why.
Sure.
So, since this is the calculator I recommended, I can show you how to factorize on the calculator, yeah? So, oh yes, so thank you for providing this, and, yeah, no, it's okay.
No, but what I was pointing at is, I think it's negative 11 plus 1.
Well, we'll use the calculator now. We'll use the calculator
No,
now.
I'm talking about the root.
Yeah, the roots are, yeah. Now, you can get the calculator to help you factorize. So, you type here mode 53. Can you try that, mode 53? It's great. What's wrong? And then you type in the A, B, and C. So here the A is 1, enter, 10, enter, and minus 11, enter, and enter. So you have 1 is the root, so that means minus 1 is the factor, and then minus 11 is the root, so that means 11 is the factor. And then here, let's go again, mode 53, and then we have 1, 10, and then minus 56. So here it's x minus 4 and x plus 14. X minus 4 and x plus 14. So, quick graph here. 1 minus 11. Do I want above or below?
Below.
Greater than 0.
Above.
Above.
So here and here, yeah. So we have x minus 11, and then x greater than 1. And then here we have 4 and minus 14. Above or below?
Below.
Below, so x is between minus 14 and 4. But remember, there's a big and between these. So if you think about it, we're looking for, firstly, let's just put in, what if I got the biggest number? 4, 1, minus 11, minus 14. So x must be less than minus 11, greater than 1, and between minus 14 and 4. So you realize the answer is only here and here. However, I also tell you x is a natural number, so we immediately can't use the negative. So we can have possibly 1, 2, 3, and 4, but then you also realize, well, we can't use 1 and 4. Why not? Because it's less than and not less than or equal to. So the answer is just going to be 2 and 3 for the x.
How do you know where to shade?
By looking at this, so this one is in red, x less than minus 11, x greater than 1, and in blue, x between minus 14 and 4.
And what difference would it make if we made the graph upside down?
Like say this one?
Like change the signs and
Yeah, okay, so like if we, let's just draw this graph upside down, you mean like this?
yeah.
And this was still minus 14 and this was 4. And if we want less than 0, it means below, which means we'd want this part and this part. So instead of this answer, we would get x less than minus 14, x greater than 4. So you'd get a different answer if the graph was upside down. So the shape does matter. The shape does matter, and the direction here matters.
But then if we flip the signs, we can.
But then this also gets flipped.
Yeah.
So like if you flip the signs, then what you would want is greater than 0, which is above, which gives us the same answer as this. So it doesn't actually matter then if you flip the signs, because you flip the inequality as well. Okay, write this down if you need to, and then... Is that his copy?
Yeah, I wrote down his name, engineering and math.
So helpful, so helpful. Lee, open it up, please. If at least you're pretending to write, it will make me feel better. Yeah. You don't yeah, thank you. No, I don't want to hear this. Don't want to hear this. Okay. What else do we need to see? So you were asking me about this one here. So I'm sure there's something else from last week. There has to be. I'm not willing to accept that you're all geniuses. Some of you, yes. Not all of you.
Give us some challenging questions
Challenging questions.
that are not in the homework.
Well, what did we do last week? What were our topics we did last week? Pascal's triangle. Oh, that was easy. What else? We did the linear and quadratic inequalities. One linear and one quadratic. Ah, right. You want a challenging question, right? I'll tell you which one to do now. See how you do with this one. If you think you're so great. Did you say we don't? From the lesson on one linear and one quadratic. Let me find which one it was. Oh yeah, as I was about to say, this calculator is on Moodle if you want to download it.
The free version is on Moodle.
Yes. Yes. Okay. One linear and one quadratic. Did I go too far?
Yeah.
It's after this one, isn't it? Oh, that's it there, isn't it? Yeah. Okay, I want people to try this last question here. This one's an interesting one. Whoops. One linear and one
2G?
quadratic. The last one, 2G, yeah.
Can you move the mouse?
I can zoom in as well. This one here.
What do you want, solving or points of intersection or what?
I'll have a cappuccino, apple pastry, and oh no, that's all for now. And then once that is done, what I also would like is you to solve this, the point of intersection, please. Answer? What did you get? So no answer, or many answers. We'll look at that in a minute. So has everybody managed to not get an answer yet? Wait, okay. Let me just write it down at least. What was the equation? 5x plus 2y equals 0, and the second one?
minus 5x squared
Mhm.
plus 8xy
G.
plus 4y squared g equals 0. Is it 4g?
Well, I don't know, the last question, isn't it? Like 2g. I have it up on the screen here.
2g.
Okay. Let's have a look at this now, or at least we can do it together. So the way I'm going to do it is I'm going to say x equals minus 2 over 5y.
I have answer.
No, you don't. Trust me on this one.
Maybe I have a mistake.
Hang on, he just saw your mistake, did you? Show it to him. There we go. Right, so what we do now, we take this, look up, guys, look up. We'll take this and we'll put it in here.
Oh.
Told you, you didn't get an answer. Right, so this one here we replace with minus 5 minus 2 over 5y squared plus 8x y plus 4y squared equals 0. And that's a y. So this will be minus 5, 4 over 25y squared, minus 16 over 5y squared. Did I make a mistake here? This one, is it?
That's 4y.
Oh, you're giving me the last part? Plus 4y squared. For this one? Oh, yeah. Sorry, I see it now. Thank you. I did something I shouldn't have done. Four y squared plus 4y squared equals 0. So that's minus 4 over 5y squared plus 16 over 5y squared plus 4y squared equals 0. That would be minus 12 over 5? Is it? No, I'm going to say not 12 over 5. Yeah, 12 over 5. For these two.
No, it's minus.
Oh, sorry, I lost my minus again. Right, so minus 20 over 5 is minus 4y squared plus 4y squared equals 0. 0 equals 0. If we don't know the y, and we don't know the x. So when this happens, what does it mean?
They don't cut the axis, they don't touch the axis.
We have a few possibilities. Maybe first possibility there's no answer because they don't meet.
Oh, they don't meet.
Possible, don't intersect. It's possible. What's another possible explanation here? It's possible that they could be any number. Kind of. I'll put a little star there. What else?
How can they be any number?
We'll see in a moment.
If they're the same line,
Hmm?
they're the same.
Yeah, that in fact, that they're the same line, or the same curve or line or whatever.
So that they touch, but and they continue touching for like,
Forever.
yeah.
Yes, I know, quite romantic. So they're the two, and they meet everywhere. They're the same actually. Okay, so which possibility is it going to be here? What do you think? Is it that they don't meet?
No, it's the
Could be
second
any
one.
number. Now, or that they're the same curve.
It's not the same.
Yes. That's all.
So we can examine to see what's happening. So the first one, that they don't meet. Well, I can easily prove to you that this one is wrong, because if I say use 0, 0, is 0, 0 on this?
No.
Yes.
Yes. Yes.
Thank you. Because it's 0 plus 0 equals 0. Is 0, 0 on this?
Yes.
So, if 0, 0's on this and 0, 0's on this, then they must meet at 0, 0. So, we can't say that they don't meet. They do meet at least once. So, it's not that they're parallel. It's not like we have some situation where they don't meet. They do meet. Now, the question is, could we use any numbers? That's the second one. So, let's say, for example, I use x is 1, let's say, and y is 1. No, I don't mean that one, sorry. Well, no, I suppose I could. 1 and 1. Is 1, 1 on this? No, is 1, 1 on this? No. What about,
So it's not any number.
it can't be any number, so it's not like you can just use any x and y, so it's not this one. So the one which you said it isn't, it is, that's the same curve. And you might be thinking, now Stephen, you're talking crazy talk, because firstly, that's linear, that is not linear. You're not going to tell me that they're the same. Are you? I am. So watch what happens now. Minus 5x squared plus 8xy plus 4y squared equals 0. That's the same as, let's try and factorize this. Right, well, it's going to be an x with a minus and a y, and an x with a plus and a y. I'm thinking,
It has to be 5 and 1 for the x.
well, yeah, but this could be a 1 and a 4, or a 2 or a 2. I'm thinking a 2 and a 2. And a... 1 and 5.
Minus 5x and x.
Minus plus 5 and 5. Let's check it. No, what are we doing? No. I know that's wrong. I know that's wrong, because it's not. It can't be 5 here. It has to be. Has to be 1. I know what will help us.
Draw the graph.
Calculator to
Use
the
the
left.
calculator.
Yes. Minus 5.
Wait, but this
X,
is
Y.
xy, it's not.
I will see what happens.
It's plus 4.
Oh, well, that's... Thank you. Two and 2/5. Okay, hang on a second. 5x minus 2. And then what was the other one? 2. X minus 2.
5x plus
Our
2.
And then there has to be a y.
Our calculator doesn't give max and minimum.
That's okay. That's okay. Right, let me just see if we can match it. That one and that one is good. That one and that one's not good. We'll need a minus in there somewhere for this. But this minus is kind of driving me crazy. I'm going to multiply everything by minus to get rid of it. It's annoying the heck out of me. 5x squared minus 8xy minus 4y squared equals 0. Better? Now let's try that again. Five minus 8 minus 4. X minus 2y maybe, and 5x plus 2y. Okay, let's check to see if that works. That multiplies that, makes that. Yes. That multiplies that to make that. Yes. Check the middle. This is minus 10y, and here, 10xy. And then this one, 2xy, total, minus 8xy. Now if you look at this, this has two possible answers. Either x minus 2y equals 0, or 5x plus 2y equals 0. Now, do either of those look familiar?
No, one of the
This was in the original. Yeah? So you know that this is 0, which means this is always going to be 0. Always going to be 0, because you know this one is going to be 0. So in other words, the point I'm trying to make is this one comes from that one there. Because this is equal to 0, it guarantees that this one must be 0, because it's these two multiplied together. But this one, we just said at the very beginning, has to be 0. So this automatically is 0. So there's nothing new here. So it's not quite that they're the same, but rather, if I try and draw the graph, this one and this one are nearly the same. What type of graph will I get here for this?
Linear.
It's a linear graph. It will be sloping down in black. Now, we don't have this graph in maths, but I'll draw the graph for you anyway. This one here I'll do in red. It's actually this and this. So the answer is anything on this line, that's where they both meet. So there's infinite answers, and it's anything on this line. In other words, anything that works for this will make this be acceptable. So for example, if you choose, I don't know, x equals 2, that's a 10, and y equals minus 5, so that's here, that will automatically work for this. I don't even have to check it. I know if I put these points in here, I will get 0. So anything on this line will work. And the reason it's 2 lines, well, if you think about it, we've written it like this. It's this or this equals 0. So the 2 lines are actually these 2 lines here. Okay, now you said you wanted a difficult one, so there you go, that's a difficult one. Oh no, it's okay. Way too difficult for the exam. Way too difficult for the exam. But since nobody had trouble last week and you're all so smart, then I thought it was... Was that an accidental cough? Or? I thought I could give you something more difficult. So another question for you to try, yes? Write that down if you need to. So just so you're clear, this last point, they don't have to be the same curve for it to be a problem. You just need them to be overlapping. Now what else could I give you that's tricky?
If you re-multiply everything by -1.
Yeah, I'm quite hungry, so I couldn't deal with the minus at the start. So that's why.
Would you like a biscuit?
What have you got?
Might be drunk.
Is there chocolate in it?
One does and the other doesn't.
Oh, I have a choice.
Yes. Or you can have both. I have an extra sandwich.
I will take this. You're so kind.
You do know that sharing is sharing.
Huh?
Sharing is not sharing.
Sure it is. Okay. Be good. Are you good?
Okay, I have a question.
Yeah.
Can I get a copy of this?
That's a request, not a question. And yes, you can. You just need to come. You mean the book?
What book? The one where you got the question from.
Oh, it's in the book.
Oh.
It's the last question on that worksheet.
Oh.
Yeah. Okay, I want to give you another one to try now. That's a little bit tricky. From the solving and sketching. Is that the next one? No, it was the one before that, wasn't it? I'm thinking which one. Something tricky. I find the ones that have, yeah, these ones I find to be trickier to draw. See how you can do with this one here. Oh, and mode 54. Now you know in the exam, well actually no, I forget that, clear that, I'll show you something else. You know in the exam you're supposed to try different values until you get a root. Yeah, we have a mode here, mode 7. Watch this now, mode 7. You type in the function, this one here, minus 7 alpha, and here's x cubed. What's next? Plus 12 alpha x squared minus 4 alpha x plus 16.
Then you choose the value.
What the heck? Okay, so we start at, what did I say is the smallest value it could be? Minus 3. And the biggest? 3. And we go up in units of 1. Minus 3, minus 2, minus 1, 0, 1, 2, 3. And then we have our table made. So here's the x and here's the y. So you can see minus 3, any good? No. Minus 2? No. Minus 1? No. 0? No. 1? No. 2. So, x equals 2 is a root. What's the factor? X minus 2.
Oh, this is good.
I know. It's a thing of beauty. So if you can try OR now, and you already know what the factor is, it's x minus 2. Okay. Try this one here, OR please.
Could you put the previous question back on after this one?
After this one, yeah. Well, no, you have it on Moodle. Oh, you mean the solution? Ah, okay. Write this question down so I can just flick it back. Are you doing this? Good.
If we get this and the answer, we'll have to divide and then get
No, that's not, that's an imaginary answer, that's no good.
oh yeah.
Okay.
I
So,
get the 2 and then the other 2 are imaginary numbers.
see, if you use the calculator too much, you forget what you're doing. Use with caution. Alright, have you done the long division? Oh, come on. Right. Did you do the long division?
Yes.
And the quadratic that you got from the long division, what's the problem with it?
All negative.
No, that's not a problem.
The imaginary.
We haven't used that word in maths class, so don't you use it.
Okay, it doesn't touch the axis.
Yes,
They don't have real roots.
thank goodness, right. So the quadratic doesn't have any roots, which means that there's only one solution. The stop, please. Let me finish. I'm capable of talking, thank you. Right. So, we know that there's a solution at 2.
Yes.
This is the one we found at the beginning. And also, we can know where it crosses the y-axis. Where does it cross the y-axis?
15.
At 16. And we also know something about the shape. Is it down, down, or up, down, up?
Depends, is it's negative.
No, down, up, down.
Or is it up, down, left,
No.
right, A, B, A, B?
No, down, up,
Okay.
down.
Down, up, down. Are you sure?
Yes.
Up, down,
No.
It's
Up.
negative.
Yep.
So it's
So up
down,
first.
up, down.
no. No, up first. Up first.
So down.
Up, down, up, if it's negative. Up. Or is
Up,
it-
down, up.
Hang on, you're confusing me too.
No.
Up,
Down, up, down.
down, up, down, yes.
Down.
No. Up, down, up. Up, down, up.
No.
Up, down.
Hang on. Down, right. This is x cubed.
Yes. So it goes up in the end. So negative x cubed goes down in the end.
So minus x cubed starts with down, up,
Oh,
down.
It's right, okay.
Yeah, no, leave me alone. Right, so it's this one here. Yep. Now we have to be careful drawing this because actually you have a few possibilities. You know, down. Yeah, so it could be something like down, up, down. That works.
Yeah.
But maybe there's something else as well. You know, it could have been maybe down, up, down. Or what else we could have? Down, up, down. In other words, we don't really know what the shape is. In other words, we can't know if the turn happens before. This is the turn happens before. Maybe the turn happens at the axis. Or maybe the turn happens after the axis. We can't really know. So we kind of have to use a table, which is fine because we have that from the program. So we can see that it's negative, as it should be, and positive before the 0. But notice how big this is. So for me that means it goes down very quickly after this point. And if we switch here, it's quite small here. And then if I go up a little bit, it's kind of about the same, isn't it? So I think the turn happens somewhere between 4 and 5. Because it's decreasing. Look, 39, 16, and then what happens?
17.
It increases to 17 and then decreases again. So the turn happens somewhere between 4 and 5. Not between 4 and 5, sorry. Between, what am I saying? Between
1 and 2.
0 and 1.
Yeah.
0 and 1.
Between the 2 and the x and the y-axis.
So just after the axis it turns. Just after the axis it turns. So it goes down, 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 and then just after the axis it turns up a little bit,
And then down.
and then straight back down. It's ugly, I know, but there's a small turn, yeah, here. So it's not as big as a normal cubic. It's a very, very small turn. Goes up to 17 and then comes back down. Okay, so for the exam, if you ever got something like this, firstly, I don't think you would get something like this because it's too difficult to draw. You would need to make a table. But you could get it. They might expect you to make the table. It's just, I've never seen it happen in the exam. And anyways, if it does happen in the exam, we have a way to find these points using something called calculus, which we will do later. Now, just so you can see it beautifully done, let's get a nice graph of it here.
Divine is the application.
Derive is the name of the program. It can solve things and make graphs and all that. This one, of course, can't make graphs.
Yeah, sadly. But I'm sure we can find another calculator online, a graphic calculator.
Well, I have the program.
Yeah.
Okay.
Can your laptop handle all of this?
My laptop's okay. Just about handles it. You should be impressed because this program is for Windows and this is Linux. Right, what was the function y equals minus 7x cubed
Plus 12x
yep, squared.
minus 4x plus 16.
Right, we'll need to zoom out. See? You can hardly see it here. It comes up a little bit before coming back down. That's a little bit better. Goes down and then comes up to 17 before coming back down. So it has a very, very small turn between 0 and 1. Down, up briefly, and then straight back down. Yeah? Okay. And if I zoom out, it's really hard to see it, but I think you agree that my graph is exactly the same as that. So hard to tell a difference, I can't. Identical. Yes. Okay. That's it for today, isn't it? We have back to classes then tomorrow. Okay. So since you didn't really have any questions from last week, that means everything is going well. Indeed. Right.